Hey, good morning. It's Thursday, April 9th. Um, I wanted to let you know that Miss Dawn and I have decided to go ahead and stretch out our assignments a little bit. We're hoping this will give you guys the opportunity to get these things done instead of scrambling. We know you have a lot of other work to do. So here we've got these assignments. This is taken from the PDF that we're all sharing. Notice that it used to be this was Tuesday, this was Wednesday, this was Thursday, this was Friday, but we've changed it to give you more time. So this week you're just working on the converse of the Pythagorean theorem, and we just need you to get the practice assignment and the quiz done by Friday. Next week we'll start using the Pythagorean theorem to solve for a missing side. And I have a couple of examples I want to show you in this video, but first we'll do Pinterest. We have to do our Pinterest. Uh-oh, that's not going to work. Let me move these up out of the way. April every year, April during the quarantine. Doesn't really matter. People are still going out anyway. People normally, people during the quarantine. I'm sure you've noticed that. Everybody, their mothers out walking their dogs and riding their bikes. I wonder if Target misses me too. I miss you, Target. Still love my Kermit. This one was kind of funny. Do you think bugs are born knowing they can walk up walls, or do they just accidentally do it in one day and go, yo? See, that's my dog barking at people out riding bikes and roller skating. She will probably bark more than once. All right, so let's look at some examples here. This is what we're doing right now. This is using the Pythagorean theorem to tell if the triangle is a right triangle. And the Pythagorean theorem is right there. It's a squared plus b squared equals c squared. And what we do in this case, let me get my pen. What we do in this case is we know that the two shortest sides are the legs. So we'll go one leg squared plus the other leg squared, and try to see if it equals the hypotenuse, or the longest side, squared. Well, 5 squared is 25, 12 squared is 144, and 13 squared is 169. Now, when you add 25 and 144, you get 169. And because these numbers are equal, that means that this is in fact a right triangle. If these numbers didn't match, then it's not a right triangle. All right? Let's look at one more quick example of that. Here we have a different triangle. The two shortest sides, 8 squared and 15 squared, should equal the square of the longest side. All right? 8 squared is 64. 15 squared is 225. I can never remember if it's 225 or if it's 215. And 20 squared is 400. Clearly, this is not going to add up. 9, 8, this is 289 equals 400. And because 289 does not equal 400, this is not a right triangle. Okay. What you're going to be doing next week, and this is just a sneak peek here, you're going to be using the Pythagorean theorem to solve for a side that's missing. And we're going to start by having you find a missing hypotenuse, just like this one, okay? And here's the way this is going to look. You're going to still go ahead and put your two short sides in as the legs. But see, here's the thing. We don't know what c is. That's what we're trying to find. So 3 to the second power is 9. 4 to the second power is 16. And we're trying to find c. 9 plus 16 is 25. Now, you might think you're done here, but you're not. Because c squared is 25. I just want to know what regular c is. Well, c squared is c times c. So what number times itself equals 25? Well, you might know that one off the top of your head, but if you get a hard one, take the square root of that number, and it will give you the answer. So we learned through this process that c is 5. Pretty cool, right? I have another example of that. With this one, same thing. I'm going to do 6 squared. My handwriting's not getting any better, is it? plus 8 squared equals the c we don't know squared. 6 squared is 64. 8, oh, no, it's not. Where's my eraser? I was getting ahead of myself. 6 squared is 36, and 8 squared is 64, equals c squared. And 36 plus 64 is equal to 100. So c squared is c times c. What number times itself equals 100? Well, 10. So c is 10. Now, sometimes we're going to be using these, the Pythagorean theorem to solve, application problems or word problems. This is an application problem. This is a baseball field, and most people know that there's 90 feet in between bases on a standard baseball field. Okay, so I did have to look it up, though, I will admit that. What we're going to do is we're going to say, well, you know what? Clearly, these are the legs, because clearly this is the longest side. Okay, and so we're going to go 90 squared plus 90 squared equals c squared. 90 squared is 8100 plus 8100 equals c squared. I'm trying so hard, but it's just not working out. 8100 plus 8100 is 16,200. And now sometimes when you put this, I don't know what times itself is 16,200. So I would go to my calculator and I would put in the square root of 16,200. And sometimes you're going to get a number that's not a neat little 10 or a 3. You're going to get something gross. And this one, I did get something gross. I got 127 point. This is one of those irrational numbers that just goes on forever and doesn't stop. In this case, the problem will usually say round to the nearest tenth, sometimes round to the nearest hundredth. If we're going to round this to the nearest tenth, that means we want one number after the decimal. In order to decide if this stays a 2 or becomes a 3, we look to the number to the right of it. The number to the right of it is 5 or greater, the 2 becomes a 3. If the number to the right of it is from 0 to 4, the 2 stays a 2. Well, because 7 is greater than 4, the 2 becomes a 3, and that is our approximate value for C. Which makes sense if you look at your problem, because if it's 90 from here to here and 90 from here to here, makes reasonable sense that that would be about 127. Okay? Well, that's just a sneak peek of what's to come next week. I hope you guys enjoy completing these lessons, and I look forward to seeing you all again very soon. All right, have a wonderful day.